Don't let the problems in this section discourage you too much. It's a pretty hard section for almost every human being. Factoring, when it's hard factoring, can just be monstrous. In fact, some of the hardest factoring in the world right now can only be done on the best computers, and that is what keeps a lot of our information safe. They make codes that are based on the difficulty of difficult factoring. So we're going to have two methods for these problems that have not a 1 in front, like a 6, 2, or 3. The more factors this number and this number have, the more possibilities there are to check. And it can get quite excruciating. So what I've done is I've tried to fill out some of the boring stuff first. I can only think really of two ways of getting a 6, and that's a 6 times a 1 and a 2 times a 3. And I've only tried one order, so for these next numbers I'm going to have to try both orders. Now we need stuff that multiplies together to give 10, and it's 1 and 10, it's 2 and 5. I need both orders, 5 and 2, and 10 and 1. So that's what I'm going to put in. 1, 10, 2, 5, 5, 2, 10, 1. And normally I would check these, because once I find it, I'm done and I don't have to do any more. But I'm trying to show you how to find all the possibilities. So I'm purposely listing them all. Now, since I have a positive 10 and a negative middle term, I believe that all of these signs have to be negative. So we're basically listing everything that can make any sense at all. Now technically we need to try all these, and if we find the one that works, then we're done, and I suspect the one that works is right down here. So I think that's a negative 15x minus 4x is negative 19x. Technically, if you don't spot it right away, you have to try each of these by multiplying them out, and so that you can do that. But sometimes there's kind of a fun little trick, and you don't have to know this trick. It really belongs more in a Math 30 class for STEM majors, but it's sort of a fun trick, and that is this. The greatest common factor of all three of these terms is 1. And since that's true, just a second, I've lost my pen. I don't like it. It's not working. I think it came back. So the greatest common factor of all three of these terms is 1. And there's a rule from number theory that says if the greatest common factor of a product is 1, then the greatest common factor of each of the things being multiplied, each of the factors, are 1. That means since this greatest common factor is 1, we don't have to try anything where there's a binomial that has a greatest common factor other than 1. Do you see this? 2 goes into 2 and 2 goes into 6. So a 2 factors out of this binomial. So that's not even possible. If we multiply those two together, all these numbers will be even. Here, 2 goes into 6, 2 goes into 10. That's not possible. Here, 2 goes into 2, 2 goes into 2. That's not possible. 2 goes into 2, 2 goes into 10. That's not possible. So we could just try this one. This will give us a middle term of minus 1x minus 60x. That's minus 61x's. And we need negative 19, so that doesn't work. This is minus 5x minus 12x. That's minus 17x. That's really close to minus 19x. So it's close, but it doesn't work. This one's minus 3x minus 20x. That's minus 23x. That's pretty close. Doesn't work. This one, as mentioned, is minus 15x minus 4x, and so this works. So once again, the first method is to try the possibilities and to try them pretty carefully and to try them for a while. So now let's try the second method. In the past 3 or 4 years of teaching this, it seems as if most of my students like the second method better, but it's up to you to choose which you like best. We are going to play the number game that we've played before but it has slightly different rules. It's not quite as simple as it was before. For instance, before we wanted two numbers that multiplied together to give this and added together to give this. We still want them to add together to give us this middle term, but now this first number is not 1, and so we need them to multiply together not to give 10, but to give 6 times 10, or 60. So when this number is not 1 out here, you've got to multiply this times this. So now, two numbers that multiply together to give 60 and add together to give negative 19. Well, 60 is 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. Which one of those seems to add to 19? Well, it's this one. So now we're going to have a negative 4 and a negative 15 and a negative 4 and a negative 15. And at this point you're probably thinking, well, that wasn't too bad. I like this. Well, yeah, except you got to know what to do next. And what to do next is kind of tricky. When people aren't sure, they haven't learned it well enough, or they didn't study well enough, or their teacher didn't teach it to them well enough, here's what they try to do. They try to do the thing that we did before in the previous section, 5.2. They try to say, well, it's going to be x minus 4 times x minus 15. There, I'm done. But this is just total and complete nonsense. Because if you try to check it, is x times x going to be 6x squared? No. Is negative 4 times negative 15 going to be positive 10? No. You would get negative 4x minus 15x is negative 19x. You would get that. But this is not correct. This is not what you do. All these numbers do for you is this. They allow you to go back to the original problem and break apart the middle term in a special way. Instead of negative 19x, we can call it negative 4x minus 15x. Negative 4x minus 15x. And you could put them in either order. It doesn't matter which order. You could have negative 15x minus 4x. And you might say, well, so what? Well, it's more than that. Not only is this a way to break apart negative 19, negative 4 plus negative 15, but factoring by grouping is now guaranteed to work, and you're going to be done in just a little bit. So now we have to remember factoring by grouping. I'm going to pull a 2x out of the first two terms. That's the greatest common factor. And I'm going to pull, it's either going to be a 5 or a negative 5, but I better pull a negative 5 out if I want to get a positive 3x and a minus 2. These then are common, so I pull out that common binomial. This is the factoring by grouping we learned how to do in section 5.1. And then what goes here is kind of what's left over outside of the 3x minus 2. So we've got a 2x minus 5. And this, believe it or not, works. And if we scroll back up, it's what we had up here, 2x minus 5 and 3x minus 2. But this is the second method. It would be a bad mistake to look at the last problem and say, well, I like that second method, so let's just do it. Because you would start off with 15 times negative, boy, I didn't like that. Whatever just happened. Let me pause. You know, you do 15 times negative 75, and you get a big, huge number, and you would get stuck pretty fast. Remember the very first kind of factoring we did. Always pull out the greatest common factor first, not because I say so, but because you desperately want to make the rest of the numbers smaller. Now we have a serious shot at this, now that we've pulled out the 5 that was hiding in each of these. Still, we have some work to do, but I'm going to do that second method on this one because I feel like it. I get to choose, and so do you. 3 times negative 15 is negative 45, and we want them to add up to 4. And so the factors of 45 are 1 and 45, which are not going to add up to 4. 3 and 15, which are not going to add up to 4. 5 and 9 have a chance because they're 4 apart. So I think it's probably going to be 5 and 9 if we play around with the right signs. Since we want a positive 4, I think the 5 will be negative. This times this is negative 45. This plus this is positive 4. And so I am ready to split apart the middle term. I'm going to call it negative 5x plus 9x. And now factoring by grouping will work. I'm going to pull out the x. And here I'm going to pull out the 3. And the 3x minus 5 is going to come out in front. And what's left is the x plus 3. And this checks. 3x times x is 3x squared. Negative 5 times positive 3 is negative 15. Negative 5x plus 9x is positive 4x. And we've got the 5. To complete the check, I would distribute the 5 through and see that I get my original answer. So this is the answer to the problem, and I used our second method simply because most students like it better.